Let's call the answer to this problem is capital I. If we can figure out capital I, we are done. We know integral value of the x, but we don't know integral value of the sin ln x. So, to simplify this integral, we can use integration by parts method. We can give priority for simple x term. Integration of the simple x we can write as x squared over 2. We can write sin ln x term as it is. Now minus integral x squared over 2 differentiation of the sin ln x. Differentiation of the sin ln x we can write as cos ln x. Differentiation of the ln x value we can write as 1 over x. After that we can cancel out denominator value simple x for numerator value square. Denominator value 2 is a constant, so we can bring 1 over 2 outside of the integral. Then we can write half into integral x cos ln x. To simplify this integral value, we can use integration by parts method again. We can give priority for simple x term. Integration of the simple x we can write as x squared over 2. We can write cos ln x term as it is minus integral x squared over 2. Now differentiation of the cos ln x. Differentiation of the cos ln x we can write as minus sin ln x. Differentiation of the ln x equal to 1 over x. Now we can cancel out denominator value x for square term and we can bring denominator value 2 outside of the integral because it is a constant value. Minus sin ln x mean minus 1 times sin ln x. So we can bring minus 1 value outside of the integral. Now we have minus 1 into half. Minus 1 into half value we can write as plus half. Instead of x sin ln x value we can write capital I. Now remove the brackets. We need to multiply x squared over 2 cos ln x and half I value from minus half. Then we can write minus half x squared over 2 cos ln x minus half into minus half I minus 1 over 4 I. We can write this minus 1 over 4 I value from left hand side. Then it will be plus 1 over 4 I. I plus 1 over 4 I we can write as 5 over 4 capital I. Then we have 5 over 4 I equal to x squared over 2 sin ln x minus half times x squared over 2 cos ln x. Now we need to substitute upper limit and lower limit. We have upper limit e to the power of 5 over 2. We have lower limit 1. Let's substitute this upper limit and lower limit to our functions. First one, e to the power of pi over 2 perfect squared over 2 sin ln e to the power of pi over 2 minus now lower limit 1. 1 squared over 2 sin ln 1 minus half again first one upper limit e to the power of pi over 2 perfect squared over 2 cos ln e to the power of pi over 2 minus now lower limit 1. 1 squared over 2 cos ln 1 e to the power of pi over 2 perfect squared mean e to the power of 5 over 2 times 2. Then we can cancel out denominator 2 and numerator 2. Then we can get the result e to the power of pi. Sin ln e to the power of pi over 2 mean sin pi over 2 times ln e. We know ln e equal to 1. So we have sin pi over 2. Sin pi over 2 mean sin 90. Sin 90 value equal to 1. Sin ln1 mean sin 0 because ln1 value equal to 0. Sin 0 equal to 0. Cos ln e to the power of pi over 2 mean cos 5 over 2 times ln e. We know ln e equal to 1. So we have cos pi over 2. Cos pi over 2 mean cos 90. It is 0. Cos ln 1 equal to cos 0 because ln 1 means 0. Cos 0 value equal to 1. Now we can write 5 over 4 times I equal to e to the power of pi over 2 into 1, 1 squared over 2 into 0 minus half e to the power of pi over 2 into 0 minus 1 squared over 2 into 1. Now we can remove the brackets. E to the power of pi over 2 plus 1 over 4. Now we can get common denominator as 4. After that we can cancel out denominators 4 value. Finally we can subject capital I value as 2 times e to the power of pi plus 1 over 5.